better place. We are smart at what we do to make our world a better place. By the help of God, to make our world a better place. By the help of God, to make our world a better place. Smart do.
Hello students, today I want us to look at enthalpy of neutralization. Enthalpy of neutralization. First of all, we want to understand the term neutralization. Neutralization is a reaction that takes place when an acid reacts with a base to form water. That kind of a reaction is called a neutralization reaction. A reaction between an acid and a base. Therefore, enthalpy of neutralization is the heat change when an acid and a base reacts to form water. The heat change when an acid and a base reacts to form water. Now, if you're forming 1 mole of water, if the acid and base react to form 1 mole of water, that enthalpy is called molar enthalpy of neutralization. That is, if 1 mole of water is formed, that is called molar enthalpy of neutralization or molar heat of neutralization. I want to give an example here of a neutralization reaction. For example, when 50 cubic centimeters of 0.2 molar sodium hydroxide solution was added to 50 cubic centimeters of 0.2 molar hydrochloric acid solution, the resulting solution or mixture, recorded a temperature drop of 2 degrees. I repeat, when 50 of 0.2 molar sodium hydroxide was reacted with 50 of 0.2 molar HCl solution, the resulting mixture recorded a temperature drop of 2 degrees Celsius. The fact that there is a drop in temperature tells you this reaction is endothermic, and therefore every enthalpy you get must be given a positive sign. So the first thing you do is we calculate heat of neutralization. We get heat of neutralization. So heat change is given by, enthalpy change is given by mass, capacity, change in temperature. Our mass here, we said our mass is the mass of the solution. To get the mass, you take the volume of the solution. Total volume of the mixture is 50 plus 50. This is total volume. The total volume is 50 plus 50, you get 100 cubic centimeters. The mass is given by volume times density times 1 gram per cubic centimeter. That go, you get 100 grams, that is your mass. But the capacity here is in kilograms. Therefore, you change that to kilograms by dividing by 1,000. Once you get your mass, this is our mass, we get capacity. Capacity is already given, doesn't change, is 4.2 kilojoules per kilogram per Kelvin. Then our temperature change is 2 degrees. We give them Kelvin. We turn them into Kelvin. So if you multiply mass of the solution, and remember you get solution by adding the total volume of the mixture, then once you have the total volume, multiplied by density, you get the mass. The total answer becomes 0.84 joules. 0.84 kilojoules. That is the heat of solution, part A. Part B, you're told to calculate the molar heat of neutralization of hydrochloric acid. This is what you do. Find the moles of hydrochloric acid that reacted. Moles of hydrochloric acid that reacted. The moles are, you have 50 of cubic centimeters, which is of 0.2 molar. Get the moles up. 50 times 0.2 moles divided by 1,000. Your answer becomes 0.0.0.0 0.01. 0.01. That's it? 0.01. Okay. Now, once you get 0.01 as your answer, then you say this is what you should understand. That if you reacted 0.01 moles of HCl, you produce enthalpy change of 84 kilojoules. So molar enthalpy, molar heat of displacement, is enthalpy change when you displace 1 mole of HCl. So if 0.01 when displaced, they produce 0.84 kilojoules. And remember, the sign is positive, that's why I left it as positive. What about 1 mole? It will be 0.84 divided by 0.01. The answer should be around 84. 84 kilojoules per mole. The answer is 84 kilojoules per mole. So therefore, when you displace 1 mole of HCl, the enthalpy change is 84 kilojoules. The other thing you asked is to write an equation for the reaction. We're writing the equation for the reaction. And what is the equation is ionic, so it should be sodium hydroxide plus hydrochloric acid. Both are aqueous. You get sodium chloride plus water. Now we break into ions. Sodium ions plus chloride ions plus hydrogen ions plus chloride ions. You get sodium ions plus chloride ions plus water. So we cancel spectator ions. Sodium is a spectator because it acquires both sides. Chloride is a spectator, acquires both sides. So what you're left is, this is sodium, sorry, this is sodium hydroxide, hydroxide. So you cancel sodium and sodium, sodium and sodium, chloride and chloride. So what you left is, this is left, that was that, and this is left, that was that. So you get OH plus H, hydrogen ions, you get water. This is the ionic equation for the reaction. whereby hydrogen ion neutralizes hydroxide ion to form water. If you are to put enthalpy change at the end, if you are to do this, if you are to do that, (84 kilojoules per mole), if you are to do that, now this reaction shall be called enthalpy, shall be called a thermochemical equation. Thermochemical equation is an equation which has enthalpy change at the end. The last one to do is energy level diagram. So this is what you do. You have your graph. This is energy in terms of kilojoules. This is reaction progress. When the sign here is positive, that means heat is absorbed. Therefore, this is sodium hydroxide plus HCl. When they react, heat is absorbed, and the product here, sodium chloride plus water, has more energy than the reactants. And the enthalpy change here is positive 84 kilojoules per mole. That is how you draw an energy level diagram. So make sure if the arrow point upward as positive, when it's negative, the arrow should point downwards. So our reaction is an endothermic reaction. I hope you've enjoyed our lesson. You can still do more questions look for more questions on enthalpy and neutralization and do them. We shall link the next lesson to do more questions.